In this video, we're going to talk about special right triangles, the 45, 45, 90 degree triangles. So you'll notice I have drawn out a 45, 45, 90 triangle, and just like the 30, 60, 90 triangle, we have some special, I like to call this the 45, 45, 90 shortcut. So you will notice that across from the 45 degrees, since they're both 45s, they have the same value. This across from this 45, they're going to be the same. So let's write that down. So across from the 45s, they're going to be the same side. They're going to have the same measure. Across from the hypotenuse, or across from the 90 degrees rather, is the hypotenuse, this guy right here. And the hypotenuse is always going to measure a times the square root of 2. So when we're doing these problems, we do them the same just like we did the 30, 60, 90 triangles, except now we just have a different shortcut. But the process is exactly the same. So I have two examples for you. In this problem right here, we have to find the missing sides x and y. So we notice that we have a 45, 45, 90 triangle. Again, like we did before, we're going to draw in our shortcut triangle in the same orientation, and we're going to label it. Across from my 45s, or my two legs of my triangle, are going to have the same measure, a, and the hypotenuse across from the 90 degrees is going to have the side a times the square root of 2. So we match up the things that are the same. 3 matches with a, x matches with a, y matches with a times the square root of 2. We can write down all of our equations. 3 matches with a, x matches with a, and y matches with a times the square root of 2. Okay, so in this equation, I already know what my a value is. It tells me from this equation right here. So that means wherever I have an a, I'm going to replace it with a 3. So here x is equal to 3, and y is equal to 3 times the square root of 2. And you can leave your answer just like that. That's the easier of the two when they give you the leg, the side that's the same. The harder of the two is when they're going to give you the hypotenuse. So again, oops, I forgot to draw it in. I have a 45, 45, 90 triangle, so I'm going to draw in my shortcut triangle in the same orientation that my triangle is drawn. I know it's a 45, 45, 90. Across from my 45s are a, and across from my 90 degrees is a times the square root of 2. I'm going to match up the things that are the same. X matches with a. This y matches with a. And, oops, sorry, I already used that color. And 6 matches with a times the square root of 2. So I'm going to write down all my equations. X matches with a, y matches with a, and 6 matches with a times the square root of 2. So once I find a, I can figure out my x and y because they're going to be the same. So here, in this last equation, here, I'm going to have to get a on a side by itself. So to do that, I have to undo the square, multiply by the square root of 2. So I'm going to divide both sides by the square root of 2. So I get 6 divided by the square root of 2 is equal to a. But remember in math, we do not have any square roots in the denominator. So we have to rationalize. We multiply the top and the bottom by whatever the denominator is. In this case, it's the square root of 2. So square root of 2 times 6 is 6 times the square root of 2. And square root of 2 times the square root of 2 is 2. In this case, we can simplify a little bit more because I can divide. 2 goes into 6 evenly. It goes in 3 times. So my final answer for a is 3 times the square root of 2. So that means wherever I have an a for my other two missing sides, I'm going to plug it in. So x is equal to 3 times the square root of 2, and y is equal to 3 times the square root of 2. And these are your final answers. Let me know if you have any questions.